In this video, we are going to discuss the February-March 2022 paper, paper 6, which is the probability and statistics 2, and the variant is paper 6.2. Right, so let's have a look for question number 1. Okay, they give us the length in milliliters for a random sample of 12 rods made by a certain machine are as follows. So these are the data that we have, right? Okay, so first they want us to find the unbiased estimates of the population mean and also the variance. Right, so to get the unbiased estimates for the population mean and also the variance, right? Generally, there's a formula for us to follow. Okay, so you can see that this is actually the formula that we should use to find out the unbiased estimator for mean. This is for mean. And for the variance, you can have two options. This is the first option and this is the second option. So according to the data that we have here, I think the second option is a better equation or better formula for us to use. All right. Okay, so let's start. So for the unbiased estimator, right, we need summation x and also summation x squared. So first of all, let's find out the summation x and also the summation x squared. So for the summation x, we try to add all the value of the data provided. So all these are the data provided. So what we do is that we try to add them together. And if you try to add them together, generally the answer that you get for the summation of x should be 2398. All right, and after that, we are going to get the summation of x squared. So to get the summation of x squared, you take every single value and you square it, and after that, you add them together. After you square every single data and you add them together, you'll get the summation of x squared, which is 479226. Okay, so now we are going to get the unbiased estimator for the mean. All right, so to get the mean formula, to get the mean, the formula should be summation of x, which is 2398, divided by the n. So the n here is 12. We are having a random sample of 12 rows, so the n should be equal to 12. If you try to simplify, you'll get 1199 over 6. Or if you want to change it to 3 significant figure answer, it should be 200. All right, so this is the answer for unbiased estimates for the mean. Okay, after that, we are going to continue with the unbiased estimates for the variance. So to calculate the variance, generally we are going to apply the second formula provided in the formula booklet. This is what we want. Okay, so 1 over n minus 1, which is 11. Summation of x squared, you already get it just now, which is this value, 479226, minus summation of x, 2398, and you square it, divided by 12. Okay, so by pressing calculator and correct your answer into 3 significant figure, it should be 2.33. Okay, so this is how we get the unbiased estimates for the population mean and also the unbiased estimates for the population variance. Right, and for next part, part number B, they are asking, give a reason, a statistical reason why the estimates may not be reliable. All right, so we are using the sample to estimate the value for the population mean and also the population variance. All right, and then why these estimates may not be reliable? One of the possible reasons is because of maybe the sample is too small and it not able to represent the data for the whole population. All right, so this is one of the possible answer. Okay, so we can say that this is a small sample. Okay, so this is how we answer question number 1. Okay, so question number 2. Harry has a 5-sided spinner with the sectors color blue, green, red, yellow, and black. So these are the 5 colors that we have. Harry thinks the spinner may be biased. He plans to carry out the hypothesis test with the following hypothesis. So you can see that they already provide us the null hypothesis and also the alternative hypothesis. Okay, so Harry spins the spinner for 300 times and it lands on blue on 45 spins. So the value for 45 here, we'll use it as the calculation for our probability later. All right. Use a suitable approximation to carry out Harry's test at a 5% significance level. Right. So this is 5%. Generally, we are going to carry on the test for the probability, the proportion of the probability. Right, generally for the proportion of the probability, the distribution that we are using here should be binomial. Okay, therefore, the 300 times here, you should know that it is actually the binomial, the n for the binomial distribution. And then the 1 over 5 here will be the p for the binomial distribution. Okay, all right, so let's start for the testing part. So first of all, of course, we are having the null and alternative hypothesis as provided in the question. So the p is actually equals to 1 over 5, and p is not equals to 1 over 5 for the alternative hypothesis. So the sign not equals to means that this is a two-tailed test. Originally, it belongs to a binomial distribution where x is binomial distributed, the n should be 300, and the p should be 1 over 5. Okay, so if you double check, you realize that the n is large and the p is small. When you get the value for n times p, it is more than 5. When you multiply the value for n times q, it is also more than 5. So due to this reason, therefore, I have to change the binomial become normal distribution. Alright, so when I change it become normal distribution, the mean, I get it from the value n times p, which is 60, and the variance should be npq, which is 48. Alright, so for your information, how to get this value is n times p. How to get this value is actually from npq. Alright, yeah, so now after you already know that you are going to change the binomial become normal distribution, when we try to carry out the test, you can either use the critical value approach or you can use p-value approach. Right, so for us, we are having a normal distribution now. Generally, I will try to use critical value approach. So for critical value approach, I need to know what's my critical value first. So first of all, I will imagine that I'm having a normal distribution graph. And since this is a two-tailed test, therefore I'm having two rejection region at each end. So this is my rejection region. This is also my rejection region. My alpha significance level is at 5%. Therefore, for this area, it will be 0.025. This area also 0.025. Okay, so which means that the total for the significance level of the rejection region, will, the area will be equals to 5%. Right, so once I know that this is the rejection region already, I try to find out what is the critical value. Okay, so to find out the critical value, we need to go through the normal distribution table to find the critical value. All right, if I take 1 minus this area, which is 0.025, I'll get the value 0.975. So to get the exact value, the critical value, we are going to look for the area or the probability of 0.975. So let's have a look for the table that we have. Okay, so we're at 0.975. So you can see that from this table, when the probability is equal to 0.975, the value of Z is 1.96, which actually means that the critical value for this part will be 1.96. And of course, on the left-hand side, since they are symmetry to each other, right? So the critical value for the left-hand side will be negative 1.96. All right, so please take note that our critical value will be 1.96 and also negative 1.96 according to the diagram that we draw here. All right, so after I find out the critical value, next one I have to find out the test statistic. So to find the test statistic, generally the formula will be x minus the mean divided by the standard deviation. But because of we are changing originally the binomial distribution become normal distribution, binomial is a discrete random variable and normal distribution is a continuous random variable. Okay, therefore the continuity correction is needed. Okay, so continuity correction is needed here. All right. So now, how can we make the continuity correction? Generally, you can have a look for the compare the value for x and also compare with the mean. So as example, when the x here that I have is 45, okay, then minus the mean, which is 60. All right, so 45 minus 60, you'll get a negative value, right? So that means your critical value will be a negative value later, right? At the negative value here, if you want to make the continuity correction, you should try to cover. That means if let's say this is the value that you calculate originally, then the continuity correction should cover the value that you want to calculate or the area that you want to calculate originally. All right. So if this is negative 1.5, then when you want to do the continuity correction adjustment, it will be plus 0.5. All right. So when you're having a negative value, so you have to cover the area that you want to find. Therefore, the continuity correction should be a plus. So plus 0.5. So for the steps here, I will write a plus 0.5 as a continuity correction. All right, so 45 minus 60 plus 0.5 divided by the standard deviation. So the standard deviation for our case here is square root 48. All right, so the test statistic value that you get is negative 2.093. So this is my exact value or the test statistic value that I calculate from the sample. Okay, or from the information given. And after that, I will want to compare this test statistic with my critical value. So if I try to put negative 2.093 into the diagram here, you will see that it is actually located at this part, which is smaller than negative 1.96. So this particular value is negative 2.093. So from here, you can observe that this particular value actually falls under the rejection region. Okay, so now since it falls under the rejection region, therefore we should reject the null hypothesis. Okay, so before we make any conclusion or make any decision, we should try to compare. All right, so the test statistic, okay, which is negative 2.093, is actually smaller than the critical value. Okay, so which is negative 1.96. Or to be clearer, you can actually observe them from the diagram. All right, so you can see that the negative 2.093 falls under the rejection region. So this is the comparison that I made, and therefore I can conclude that we should reject the null hypothesis. Okay, so what is the meaning when we reject the null hypothesis? It actually shows that there's enough evidence to show that uh, the spinner is biased, right? Okay, yeah, so this is the complete steps, all right, how we actually carry out the test for this um, hypothesis test on the proportion. Question number 3. We have a random sample of 500 households in a certain town was chosen, and then by using this sample, they calculate a confidence interval for the proportion. All right, so the confidence interval for proportion, and it was found that this is the confidence interval. All right, so they want us to find the confidence level for this confidence interval, and we have to give the answer correct to the nearest integer. All right, so first of all, we are given this confidence interval, and the limit is 0.355 and also 0.445. So first of all, we can actually calculate the value for the proportion by finding out the midpoint for these two limits. So it will be 0.355 plus 0.445 divided by 2. So the proportion is actually the limit, the midpoint, okay, for these two limits, which is 0.4. So if P is equal to 0.4, automatically you should know that Q is equal to 0.6 because P plus Q should be equal to 1. All right, then now by using either of the limit given in the question, you can use a upper limit or you can use a lower limit as well. So it depends on your preference. All right, so I'm using upper limit here. So for this upper limit, right, I know that the formula for the upper limit of a confidence interval for proportion is P plus Z square root PQ over N. And the value that I get here given in the question is 0.445. Okay, so I try to substitute in all the value that I know. So P is a 0.4. Z, I don't know yet. Okay, so the P here is 0.4, Q is 0.6, and the sample size is 500, and it is equals to 0.445. Alright, so by equate the formula, the upper limit formula with the 0.445, my aim is to find out the value of Z. So the value of Z, if I calculate it from this step, I will get 2.054. Okay, so this is the value of Z that I have. Alright, so let us continue to find out the confidence level. Alright, so according to the understanding of confidence interval, right, it actually forms, it is actually from the normal distribution. Alright, and then the confidence level is actually the center part. Alright, so for the confidence interval, so that means they want us to find out this confidence level, and the value of Z is actually the Z value, okay, at the that separate lah, okay, or that separate the confidence level with the significance level, right? So this is the value of Z, and Z is equals to 2.054. All right, okay, so now I try to find out this area. So if I try to find out this area, generally I'm having the probability of Z, which is greater than 2.054. So from the normal distribution table, I will get 1 minus, and now I'm going to look for the 2.054. So this is 2.05 is here, and then 4, you have to add the 2 at the last digit here. 9798 plus 2, you will get 9800. So 1 minus 0.9800, and therefore you get 0.02. So which means that this area is actually 0.02. At the same time, since the confidence interval are symmetrical, right? Therefore, this area should be also 0.02. So the center part here will be actually my confidence level. So how to calculate the confidence level for this part? Generally, you should know that to find out the confidence level, it should be equals to, you should take 1, the whole area under the graph is 1, right? Minus 2 times of 0.02, and you have to multiply it with 100%, so that we get the confidence level. All right, so 1 minus 2 times of 0.02 multiplied 100%, you will get a 96%. Therefore, the confidence level should be 96%. Okay, so this is how we answer question number 3. Okay, so we come to question number 4. In the past, the time in minutes taken by students to complete a certain challenge has a mean 25.5 and also the standard deviation 5.2. Thus, a new challenge is devised, and it is expected that the student will take on average less than 25.5 minutes to complete this challenge. All right, so the keyword less than give us an idea, right, to form the alternative hypothesis. Right? So less than means less, smaller than, no equal sign. Therefore, it is actually to help us to form the alternative hypothesis. So should be less than 25.5 minutes to complete the challenge. A random sample of 40 students, so our sample size is 40. which is the n. Okay, is chosen and their mean time for the new challenge is found to be 23.7 minutes. So this is also the mean. Okay, but this mean time 23.7 is actually from the random sample of 40 students. Therefore, you should understand that this is actually a sample mean, and the 25.5 here is actually the population mean. Okay, all right, so this is all the information that we have. Assuming the standard deviation of the time for the new challenge is also 5.2 minutes, which is the same as the population standard deviation, test at 1% significance level whether the population mean time for the new challenge is less than 25.5%, 25.5 minutes. So again, so you can see this keyword again, less than, to help you form the alternative hypothesis. Right, so we are going to test whether the mean is less than 25.5 minutes or not. So let us start. The first step, we should try to form the alternative and null hypothesis. Okay, so for the null hypothesis, it will be equals to mean equals to 25.5 minutes. And we are going to test whether the new challenge timer is less than 25.5 minutes. So mu will be smaller than 25.5 minutes here. Okay, so for this question, we don't know whether the population is normally distributed or not, but since our sample size is large, which is equals to 40, therefore by applying the central limit theorem, we know that the sample mean is also approximately normal distributed. All right, so which means we can carry out the test by using the normal distribution. Okay, all right, so if you want it to be more detailed, generally you should know that the sample mean should be normally distributed where it is equal to the population mean, which is 25.5 minutes, and the variance should be the population variance. So this is a population variance, right, divided by the n. So the n here will be 40. Okay, all right, then since we know that this is a normal distribution, right? Okay, so first we will want to use the normal diagram or the normal graph to help us visualize the whole test here. Okay, so I'm having a normal distribution. Okay, because for this question, the alternative hypothesis is one side, that means smaller than. So for the smaller than alternative hypothesis, it means that our rejection region will be on one side only, which is on the left. So this is my rejection region. And then how big is the rejection region here? It is equals to the significance level, which is 1%. So this area should be equals to 0.01. For now, I'm interested to get the critical value at here. So what is my critical value? So to get the critical value, generally you have to look for the area 0.99. 0.01, you won't get any area for 0.01 from the normal table. Therefore, you should look for the area 0.99. All right, and I want to get the value for Z for the area 0.99. Right, so again, I go back to the table. For the area 0.99, this is area 0.99. The value of Z that I get should be 2.326. The critical value here should be 2.326, but with a negative in front, because from this diagram, it is clearly shown that the value, the critical value should be a negative value. All right, so the Z should be negative 2.326. Okay, so I successfully found the critical value. Next, I'm going to calculate the test statistic. So to calculate the test statistics again, test statistics. Okay, so for this distribution, right, we are going to use a sampling distribution. Therefore, the formula will be x minus the mean divided by standard deviation over square root n. So what is the sample mean that we have? 23.7. What is the population mean? 25.5. What is the standard deviation for population? It will be 5.2. and what is the square root n? It will be square root 40. So from here, if I try to calculate the test statistic, I will get negative 2.189. Okay, so after I get the test statistics, I will want to make a decision by comparing the test statistic with the critical value. All right, so to visualize it clearer, right? So I will try to put the test statistic inside the diagram that I draw just now. So negative 2.189, I compare it with negative 2.326, and I realize that this value, negative 2.189, should be larger than negative 2.326. Therefore, when I draw it, I will draw it before the negative 2.326. When I put in the test statistic into the diagram here, you can see that the line clearly falls under the acceptance region. This is the rejection region, right? By the side, at the end side. So this area should be actually the acceptance area or acceptance region. So you can see that test statistic falls under the acceptance region. Therefore, we should accept the null hypothesis. Okay, so before I make any conclusion, I'll write out the comparison result where my test statistic which is negative 2.189, all right, is greater than the critical value, which is negative 2.326. So again, from the diagram, you can see very clearly that it falls under the acceptance region. Therefore, our conclusion will be do not reject the null hypothesis. Okay, so which actually means that we do not reject the null hypothesis. So that means there's no enough evidence okay, to show that the mean time for the new challenge okay, is less than 25.5 minutes. Less than okay, so this is how we actually carry out a complete test. Right, and it belongs to normal distribution. Okay, then now let's continue to part B. So for part B, they are asking us to state with a reason, all right, whether it is possible that type 1 error was made in this test. So our test in part A is do not reject the null hypothesis. Okay, so what's the definition for type 1 error? So type 1 error means that we reject the null hypothesis given that the null hypothesis is true. Okay, so this is our definition for type 1 error. So for type 1 error, the definition involves the reject null hypothesis. But in our test just now, our conclusion is do not reject the null hypothesis. Okay, where you can see that it is impossible for us to have type 1 error because our conclusion is contradict with the definition for the type 1 error. All right. Therefore, it is impossible for us to make a type 1 error. Okay, so why? Because the null hypothesis is not rejected. Okay, so because the null hypothesis was not rejected. Therefore, it is impossible that we will make a type 1 error in this case. Okay, so question number 5. All right, so they give us the height. The height of buildings in the large city are normally distributed. So this is an important keyword, all right, with mean, which is 18.3, and also standard deviation 2.5. Okay, so this is for the height for the buildings in a large city. Okay, and they want us to find the probability that the total height of 5 randomly chosen buildings. So now the keyword here will be the total height. Okay, and they want to find out the probability that the total height is more than 95 meter. More than 95 meter means that we will want to write it become greater than 95 lah. Okay, so let us have a look for the total height first. Okay, so the word total means that we are having the 5 buildings and we are looking for the total. So total, I will maybe denote it by using the symbol T, which is the total. And if I want to find out the mean for T or the expected value for T, you should take first building's mean, which is generally 18.3, plus the second building, which is also 18.3, and you add it for 5 times because you're having a 5 buildings, right? Okay, or you can take 18.3 multiply with 5, then from here you'll get the value, which is 91.5. So this is the mean value for the T, and I also need to find out the variance. Okay, the variance for the total of the 5 buildings. So for one building, the variance is 2.5 square, and you're having 5 buildings in total. Therefore, you have to add the variance all together, okay, for 5 times as well. Or you can take 2.5 square multiply with 5. And for the variance that you get for the total height for 5 buildings will be 31.25. Alright, and generally because the original building, the original distribution for every single building is normally distributed, therefore the total should be normally distributed as well, where you are having 91.5 and also 31.25. Okay, so for this question, they want us to calculate the probability for T, the total height, which is more than 95 meter. So this is the symbol that we have. Since T is a normal distributed, right? It's a normal distribution. Therefore, we have to standardize to become the Z. So how to standardize to become the Z? You have to take the value for T minus the mean for the T, which is 91.5, divided by the standard deviation, which is square root 31.25. Okay, so from here you'll get the Z value, which is more than 0.626. And from here we are going to find out the normal distribution table to get the probability. So greater than, for normal distribution they only give us the value which is smaller than, so I have to take 1 minus the value from the normal distribution table to get the area that we want. So 0.626, 0.6 is here, 62. So generally we are looking at this value. Okay, and after that we need to have a look for the 626. So for the 626 here, you need to add 19 to the last 2 digits of this value. So 7324 plus 19, and the probability that we get will be 7343. So I have to minus 0.7343. All right, so this is a value given in the table where it represents the area that's smaller than 0.626. So we are looking for larger now, therefore I have to take 1 minus, right? And when I take 1 minus, I will get a value 0.2657, and you want to change it become 3 significant figure, we will have 0.266 as the final answer. Okay, so this is how we calculate the probability for the total height for 5 buildings in this case. Alright, okay, then now let's proceed to part number B. Okay, so for part B, they are saying that they are asking us to find the probability that difference between the height for 2 randomly chosen buildings. So now you're having 2 buildings and they are interested in the difference between the two buildings. Okay, so for these two buildings, right, you can denote it by building number 1, which is maybe the x1, building number 2, which is x2, and the difference. Difference means that it can be x1 minus x2, or it can be x2 minus x1. Both are belongs to, both are having the same meaning, which is the difference between the height for two randomly chosen building. Okay, so no matter it's x1 minus x2 or x2 minus x1, right, their distribution will be the same, where they are still normal distributed. And to calculate the mean for either x1 minus x2 or x2 minus x1, the value will be the same as well. All right, so now I'm just trying to find out the mean for x1 minus x2. Okay, so the mean for x1 minus x2, what will it be? Generally, it will be mean of x1 minus the mean of x2. So our original mean is actually 18.3, right? So we are having 18.3 minus 18.3, where you get the mean, it is equals to 0. And then to get the variance for x1 minus x2, so the variance for the building is 2.5 square. And for the variance that's so minus, it is always a positive. All right, so it is always a plus. And then the variance for the second building also 2.5 square. So when I try to add these two together, generally I will have 12.5. Okay, so this is actually distribution for x1 minus x2. And it is also normally distributed where the mean is 0, and then the variance will be 12.5. Okay, so now continue to the question. They want us to find the probability. Therefore, we are having the probability. The difference between the two building x1 minus x2. So like what I mentioned just now, right? The difference between the two buildings, it can be x1 minus x2, or it can be x2 minus x1. Generally, when we want to write out the symbol for this kind of cases, we are going to put the modulus. So the modulus here actually means that it can be x1 minus x2, or it can be x2 minus x1. All right. And then they are saying that the difference is less than 1 meter. Therefore, I'm having smaller than 1. Okay. And now, for modulus x1 minus x2 smaller than 1, expand the modulus function. I'm having the x1 minus x2 between -1 and +1. And since this is normally distributed, right, x1 minus x2, therefore, to calculate the probability, we should try to standardize the variable. So to standardize it, you need to take the value for x minus the mean divided by standard deviation. Okay, and then our x1 minus x2 will become the z because they are normally distributed and we are standardizing them. And then for the 1, I'm taking the value for x minus the mean divided by standard deviation as well. Okay, try to simplify all the values here. I will get negative 0.283 z, then 0.283. Okay, so for this area where the z is between negative 0.283 until positive 0.283, right? There are many ways for us to calculate out the probability. So maybe you can visualize the area first. So assume that this is a symmetry graph, and then this is 0.283, this is negative 0.283. And in our steps here, generally we are interested to find out the value that's in the center. So this is actually the area or the probability that we are going to find out. We are interested to find out. Okay, all right. So to find out this area, there are a few ways that you can do it, where you can take one means the total area under the whole graph minus 2 times of this one. This area in red color are the same for both of them, right? Because they are symmetrical. Therefore, this area and also this area on the right should be the same. Therefore, you can choose to take 1 under the graph minus the area for this one. So 2 times of z greater than 0.283. This is one way. All right. Another way is you can also continue from here. You can also rewrite it become z smaller than 0.283, where 0.283 smaller is this area purple color. Okay, and minus the area for z smaller than negative 0.283. So when I take purple color minus the highlighted green color part, this green color part is z smaller than negative 0.283. So if the purple color minus the highlighted green color part, you also get the area in the center here. All right, so for this kind of probability, there are many ways that you can solve it if you want. Okay, you can always use a diagram to help you if you want. All right, so for my step here, I'm trying to figure out this one. All right, so I take 1 minus 2 times of this area. All right, and then let us continue. Okay, so to get the probability, I have to take 1 minus 2 times of z greater than 0.283. So in the table, we don't have z greater than 0.283. I have to take 1 minus z smaller than 0.283. So again, I'm looking for the normal distribution table, 0.2 and 8. Okay, so you get this value, which is 6103. And we are going to look for 3, right? 0.283. So the 3 here will give you this value 12. That means you have to take 6103 plus 12 at the last 2 digits. So 6103, when you plus 12, the answer that you get should be 6115. Okay, it should be 6115. Therefore, I have to take 1 minus 0.6115. Okay, so after you write the steps, by using the help of calculator, you can try to get the answer. If you didn't do any careless mistake, this answer should be 0.223. Okay, so this is how we calculate the probability for this question number 5. So let's discuss question number 6 here. We are having a game, right? In a game, the ball is rolled down a slope and along a track until it stops. So the distance in meters, they are talking about the distance in meters. All right, traveled by the ball is modeled by the random variable x. So the x means the distance traveled by the ball. Okay, and then they are having the probability density function as shown here. Okay, then basically you can see that the distance traveled of the ball, right, can be from 1 until 3 meters only. Right, then after that they say that the k is a constant. Okay, so first question, without calculation, explain why the expected value of x is equals to 2. Okay, so first of all, you need to know that the mean, okay, expected value ex, ex is also having the same meaning as mean. Okay, then why the mean for this question is equals to 2. Alright, so before you can answer the question, you need to have a basic concept on the mean of random variable, continuous random variable, where the probability density function is symmetry. So as an example, if let's say I'm having the x, the probability density function, the graph maybe is a horizontal line, and then the value of x, we are taking it from 0 until 4. So this is generally this is a symmetrical function, right? Fx, it is a symmetrical function from left to right. Okay, it is a symmetrical function. So when you're having a symmetrical function, then by default, the mean will be actually in the center of it. Therefore, the mean will be equals to 2. Okay, so as another example, if let's say I'm having another function, where it is still a horizontal line for the fx, but the value is from 0 until maybe 5. Okay, so since horizontal line is a symmetrical function from 0 until 5, therefore by default you need to know that the mean is actually the midpoint that we define the value of x from 0 until 5. So the midpoint will be 2.5. Okay, so what kind of symmetrical graph we still have? Right, so you might see some graph like this. We might have a triangle graph like that. Maybe the function fx, after you sketch it out, you might get something like this. So if let's say it is from 0 until 6, then by default, because again, this diagram, the triangle here, okay, I assume that the slope, okay, they are maybe isosceles triangle, right? So by default, if I say this is symmetrical function, right, then the mean will be actually the midpoint from 0 until 6, and the mean will be equals to 3. Okay, all right, so this is a basic concept that you need to know about the mean for a continuous random variable. So let us come back to our question here. You can see that our function is negative k, then x minus 1 and also x minus 3. If you try to expand this bracket, right, basically it is a quadratic function. And if you try to sketch it out, you know that, okay, for when fx equals to 0, we are having the value x equals to 1 and also x equals to 3. That means the x-intercept for this particular curve will be x equals to 1 and also x equals to 3. So if I want to sketch it out, it might be something like this. I know that my curve will pass through the 1 and will pass through the 3. And then because you're having a negative value here, right? This negative value, when you're having a negative value with x squared, negative x squared, all right? If you expand the bracket, you'll see negative x squared here. Generally, it tells you that you are having a quadratic equation, which is an N shape, right? So since you already know just now that your x-intercept will be at 1 and 3, and your graph for your function fx will having this particular shape here. Therefore, when you try to sketch it out, the graph will look something like this. And you should know for any quadratic equation, right? Okay, they should be symmetrical from the x-intercept that we get. Therefore, by default, like what we learned just now, the basic concept here, since it is a symmetrical quadratic curve, therefore the mean will be at the midpoint between 1 and 3. So the midpoint will be a 2. Alright, so what's the reason here? So you can tell them that this is a quadratic curve. And then it is a symmetrical. Okay, so the mean will be the midpoint where the function fx is defined. So for our case here, right, our function is defined from 1 until 3. Therefore, the mean of x is equals to 2. So basically, this is a reason, okay, so why the mean is actually equals to 2. So there's a basic concept here. Of course, this result can be proved by using some integration proving, right? But in exam, you can straight away apply it. Like you need to show, right? Why is it like this? But you just need to have the concept where when you're having a symmetrical function, all right, then the midpoint will be always the mean for that particular continuous random variable. Right. Then now you can proceed to question number B. They want you to show that k equals to 3 over 4. Right, so to show that k equals to 3 over 4, we want to use the basic concept also about the continuous random variable, where if I integrate from negative infinity to positive infinity for the function fx, right, it will be always equals to 1. That means the area under the graph is always equals to 1 because your total area cannot be more than 1, right? Okay, then the negative to positive infinity here basically means the value of x, okay, that the function is defined. So for our case here will be from 1 until 3, right? So if I try to put in all the values are related to this question into the general formula here, I will have my value of x from 1 until 3.
Then my function fx is negative k, x minus 1, x minus 3. Okay, then dx, and I will let it equals to 1. Okay, so since the k is a constant, negative is also a constant, negative k, I will take it out before the integration. And then for this two particular bracket here, I will need to expand it because I can integrate the function here. So I'm having x squared minus 4x plus 3 dx, and it is equals to 1. Okay, then you can start the integration now. So the integration here basically is quite straightforward. It's a simple type of integration. So integrate x squared, you are having x power 3 divided by 3. Integrate 4x, you will have 2x squared. Then integrate 3, you will have 3x. You have to substitute in the value for 3 and also 1. And then it is equals to 1 again. Okay, so substitute in the value very carefully. You are having 9. Substitute 3 inside the x power 3. Substitute 3 into the x squared and so on. So you're having 9. Then minus 18 plus 9. Minus, now you have to substitute the 1 inside the expression. So substitute it into the first term, you're having 1 over 3. Substitute into the second term, you're having negative 2. Then the last one is plus 3. And you let it equals to 1. Again, simplify the value inside the bracket, you're having negative 4 over 3. It is equals to 1 as well. Therefore, the k value will be equals to 3 over 4. So this is the value that they want us to show, right? Okay, so this is what we have for part number B. Okay, then continue to part C. For part C, they want us to find the variance of x. Okay, so to find the variance of x, the general formula of variance x will be expected value of x squared minus the mean square. Okay, so I already have the value of the mean just now, right? They already tell us that the mean is equals to 2 in part A. So now we need to try to find out this one, the expected value for x squared first. Okay, so how to find the expected value for x squared? In general, right, to find the expected value for x squared, you need to multiply the x squared with the function fx before you start integrating the function. Okay, so this is a general formula, and now I want to apply it for this question in our paper. So our x value defined is 1 until 3. Multiply x squared with the function fx. So my function fx just now is negative k. So I'm having negative 3 over 4 now, right? So this is negative k. Then x minus 1, x minus 3, then dx. Okay, and again, I prefer to take out all the constant before I apply any integration. So you can see from here, I will take out the negative 3 over 4, and then I will multiply, I will expand these two brackets and multiply x squared with every single term. So if you multiply x squared inside the expansion, you will have x power 4 minus 4x power 3, then plus 3x squared dx. Okay, so from here you can start to integrate all the expression here term by term. Okay, so again, it is a simple integration. Alright, so I'm having x power 5 divided by 5 after integrate x power 4. Then this one I will have x power 4 itself, and then I'm having x power 3. Then again, I need to substitute in the value 3 and also 1. Okay, so put in the value of 3 inside all the terms here. Okay, by right, you should have 2, 4, 3 over 5. Then minus 81 plus 27. After that, substitute the 1 inside all the 3 terms here also in the square bracket. You have 1 over 5 minus 1, then plus 1. Okay, so again, just try to simplify all the values by using your calculator. Okay, so you should have 21 over 5 for ex squared. Okay, so please take note, this is not the answer for variance x yet. There are a lot of students, right, they always thought that ex squared, expected value of x squared, is the variance x. Basically, it is not, right? So you need to carry out one more step extra to find the variance. So like what I show you here, the general formula for variance is this one. Okay, so we'll continue from this part. So to find the variance x, basically it is ex squared, expected value of x squared, which is 21 over 5, minus the mean square, right? So the mean is 2, given in part A just now. So you take ex squared minus the mean square, and by right you should have 1 over 5 as the variance of x. Okay? Right, so let's proceed to part D. Okay, so now they are talking about something extra. We are having one turn consists of rolling the ball 3 times and noting the largest value of x obtained. So that means for every single turn, I need to roll the balls for 3 times, and then the largest x, the largest value will be denoted by x. Okay, so that means as an example, let's say I have a first throw, second throw. I roll the ball for first throw, first time, second time, and third time. Right? So let's say for the first time, my ball roll for 1.5 meter. The second time, my ball roll for 1.4 meter. And then the third time is 2.6, let's say, okay? So for these 3 rolls, right, it will give you the result where the x is equals to 2.6. Because here they say x is actually the largest value, okay? So the largest value for the 3 throws. So out of the 3 throws here, you can see that the largest value is 2.6. Therefore, for this particular term, the x is equals to 2.6. Okay, so that's the meaning for the x here, right? Okay, then now they say if the largest value is greater than 2.5, then the player scores a point. That means if let's say the x, the largest value is the x, if the x is more than 2.5, then you'll get 1 score. Okay, so 1 score. This is a score. Score equals to 1. Alright, so basically this is the meaning of the question. And now what they are asking for. So they want you to find the probability that on a particular turn, the player scores a point. So on a particular turn means that now when you roll the ball for 3 times and then you score a point at last. Okay, alright. So basically if you want to get a score, right? Get a score. There are many possible cases for you to get a score. So as an example, if I have the first row is 2.5, or maybe I put it as this one. The first row is more than 2.5. And then the second row is maybe less than 2.5. And then the third one is less than 2.5. So of course, for my x here, it will be the score for this one, right? So x will be maybe more than 2.5, and then the score will be 1. Okay, but it is possible also that we are having more than 2 rows, which is more than 2.5. And I also get the score 1. There are too many cases for us to consider. If let's say I want to consider all the possible cases, okay, so that I can score, I can get the 1 score. Alright, because as long as in any of these 3 rows here, right, okay, as long as the distance traveled is more than 2.5, then your x will be more than 2.5, and then you'll get the score. So maybe for me, if I want to make my steps shorter, what I want to consider is I might want to consider all the 3 rows here that I get is less than 2.5 meters. Okay, if all the 3 score here are less than 2.5 meters, right? Generally for my x, it is also less than 2.5. No matter which one is the highest, maybe this one is 2.49, this one is 2, this one is 1. So my score for x is 2.49, right? It is still less than 2.5. As long as I have the value of x, which is less than 2.5, then I will have 0 score. Okay, so if I try to find out the probability of getting all the 3 rows are less than 2.5, then I'll get a 0 score. So to find out the probability of get 1 score, I can take 1 minus the 0 score probability. So this is what I plan to do. I plan to carry on to find out the test, to find out the answer, the probability. Okay, so for me, I will focus on finding out all the three rows that's less than 2.5. Okay, right. So first of all, I want to find the probability first. So the probability for for one row that is less than 2.5 is, I want to get the integration from 1 until 2.5. I want to know what's the probability, right? So when I integrate, I will integrate from the minimum value, which is a 1, okay, until the value that I want, which is 2.5 here. For continuous random variable, well, no matter got equal sign or no equal sign, it doesn't matter lah. So when you integrate, you have to integrate until the particular value, which is 2.5. Okay, then I've put in the value for function fx, negative 3 over 4, x minus 1, and then x minus 3 dx. Okay, so again, negative 3 over 4 is a constant. I prefer to take it out. And then I expand the bracket first. I'm having x squared minus 4x plus 3. Okay, then again, this is a basic integration one more time. X power 3 divided by 3. Then 2x squared plus 3x. Then you're having 2.5 and 1, right? Okay, substituting the value for 2.5 and also 1. For me, I'm getting all these. You can double check and see whether your answer is correct or not here. This is the value that I get after I substitute 2.5. And then the value that I get after I substitute 1 is this one. And then I'm getting 27 over 32. Okay, so this is a probability that I get a row of the ball that travel less than 2.5 meter. Okay, this is for single row. Single row. One row, okay? So the one row distance is less than 2.5. Okay, because for one turn, I'm having 3 rows, right? Okay, then to calculate the probability that not scoring, to calculate the probability that score 1 point, so maybe I can write it like this. To get the probability of score equals to 1, okay, so you can take 1 minus all the 3 rows are getting less than 2.5 meter. So that means for single row is 27 over 32. For the second row, you also want to have 27 over 32. For the third row also, you're having 27 over 32. Okay, or of course, you can make it become, this one become 27 over 32 power 3 lah. It's the same. Alright, so I write out like this here to show you that all these represent the 3 different rows here. First row, less than 2.5. Second row, also less than 2.5. The third one, also less than 2.5. So end up, this is a probability that you do not score. You didn't score. Okay, but for the question, they're asking for score equals to 1, right? So you can take 1, then minus the score equals to 1. And by right, you will get a long decimal number, which is 0.399322598. And of course, you have to correct it to 3 significant figure where your final answer should be 0.399. Okay, right, so this is how we answer question number 6.
Okay, so we are now at the very last question, question number 7. Okay, so we are having 2 ponds, A and B, and then each contain a large number of fish. All right, so it is known that 2.4% of the fish in pond A are carp, and also 1.8% of the fish in pond B are carp. Random sample of 50 fish from pond A and also 60 fish from pond B are selected. Okay, so from this sentence or paragraph, right, generally we know that the A is actually binomial distributed, where we're having 50 fish from pond A and the percentage for the carp is 0.024. The same thing happened for pond B. We are having the binomial distributed, okay, also binomial distributed, and the total number of fish is 60, and then the percentage is 1.8%, which is 0.018 for the probability. Okay, so this is generally what we have lah. And then now they are asking us to use the appropriate a Poisson approximation. So that means we have to change binomial become Poisson. And they want us to find out at least 2 cups from A and at least 2 cups from B. So let us try to change it become Poisson first. So for A, if I want to change it become Poisson, the parameter inside the Poisson is the mean. So how to get the mean from binomial distribution? You should take 50 multiplied with 0.024. So 50 multiplied with 0.024, I'm having 1.2. Same thing happened for the B. I'm having a B here and then Poisson. So to get the parameter inside the Poisson, it should be mean, which is 60 multiplied with 0.018. And I'm getting 1.08 for the pond B. Okay, so again, for your information, to get this value, it should be n times p. Same thing happened for this one. All right, and now when we want to calculate the probability, they are asking for at least 2 cups from pond A. So that means A should be greater or equals to 2, multiply with at least 2 cups for pond B as well. So B greater or equals to 2 as well. Okay, and from here, if I want to calculate the probability, for Poisson distribution, we cannot calculate A greater equals to 2 because you have to start from 2, then 3, 4, 5 until infinity. So to calculate the probability for greater than, I will take 1 minus A equals to 0 and A equals to 1. So E negative lambda, A equals to 0 will give you the value 1. A equals to 1 will give the value lambda, which is here, this one. Okay, and multiply with E negative lambda. Right? And now for pond B. So for pond B also the same. I have to take 1 minus E negative lambda. B equals to 0. It will give you a 1 multiplied with E negative lambda. And B equals to 1 will give you the value 1.08 multiplied with E negative lambda. Okay, so this is generally the steps that we should follow. And if you use calculator to get the answer and simplify them, correct to 3 significant figure, it should be 0.0991. Correct to 3 significant figure. Okay, so this is how we solve the part A, number 1. Okay, so let's continue to part number 2. Alright, so for part number 2, now they are saying that the sample contain at least 4 cups altogether. So altogether means that total, all the fishes in pond A and pond B are included. Alright, so to me, I'll define it as the total. The total for the A and B. Therefore, we are having A plus B. Since A is Poisson distributed, B is also Poisson distributed. When you are having A plus B, they are also Poisson distributed. And the mean now will become the total of the mean from both ponds. So 1.2 plus 1.08, it is equals to 2.28. And now we want to calculate the probability for A plus B, which is greater equals to 4. So to calculate the probability for greater equals to 4, you have to take 1 minus that. So you have to take 1 minus A plus B from 0 until 3. So it will be E negative lambda. When the A plus B equals to 0, first term is always a 1. A plus B equals to 1, the second term is always the lambda. And then when you're having A plus B equals to 2, it will be 2.28 squared divided by 2 factorial. When A plus B equals to 3, it will be 2.28 power 3 divided by 3 factorial. And of course, all these terms have multiplied with E negative lambda. And if we try to continue further and simplify it, I will have 0.197 for this question, correct to 3 significant figure. Okay, all right, then now the part B for question number 7. Okay, so for part B in question number 7, now they are telling us that we have the random variable x and y with this distribution, and there are two information given here. They want us to find out the value for k. Okay, so the value of k, k is a non-zero constant. All right. So from the first information given in this question, I'm going to form an equation. All right. So they are saying that x equals to 0 equals to the square of the probability y equals to 0. Okay, so the probability of x equals to 0 will be e negative lambda power 0 divided by 0 factorial. And then for the probability of y equals to 0, I'm having e negative lambda, e negative mu, okay, then mu power 0 divided by 0 factorial, which is a 1, all right, and then I square it. From here, very easily, you can get a first equation that involves the lambda and also the mu. So you can see that lambda is actually equals to 2 mu. And this is my first equation from the first information provided. All right, then now I want to get the second equation. So second equation is I'm using this second information provided in the question. So I'm having x equals to 2 equals to k times of the probability of y equals to 1. And I square it. All right, so for the probability for x equals to 2, I'll have e negative lambda power 2 divided by 2 factorial equals to k. I just copy. The probability of y equals to 1 will be e negative lambda power 1. Oh, sorry, it shouldn't be a lambda, right? It should be a mu. Okay, so let's start again. E negative mu, then mu power 1 divided by 1 factorial, and then I have to square the whole thing. Okay, so for this part, I'm having e negative lambda power 2 over 2. And for this part, if I try to multiply in the square into every single terms here, I will have e negative 2 mu, and then I'm having mu square divided by 1 factorial is a 1. Okay, all right, so from here, I'm going to try to simplify it. Since I know that lambda is equals to 2 mu, so I substitute the lambda equals to 2 mu in our expression here. I'm having e negative 2 mu, and then I'm having 1 over 2, and then I'm having 2 mu squared. Lambda squared means 2 mu squared. Okay, and then equals to k e negative 2 mu and then mu squared. All right, so if I further investigate this one, e negative 2 mu and e negative 2 mu can be cancelled off. All right, then I'm having 1 over 2 here. 2 mu squared will give me 4 mu squared, and then k mu squared. And again, mu square can be simplified one more time, and then 4 and 2 can be simplified also. And from here, you can see very clearly that the value of k is actually equals to 2. Okay, so this is how we find out the value of k. Alright, so here is the end of the video. Alright, so thank you very much for watching.